All right, let's dive in. We're going to explore this really powerful method for making things, well, just better, faster, cheaper, you name it. It's this genius shortcut that has quietly been changing the game in countless industries, everything from engineering to medicine.
I mean, think about it for a second. How do you find the absolute best way to do something, right? Whether you're trying to bake the most amazing cake, or design a bridge that's way stronger, or even create a more effective drug, finding that one perfect recipe can feel, well, almost impossible.
You know, the most straightforward approach sounds simple enough. Just try everything. This is actually a real scientific method called a full factorial design, which was pioneered way back in the 1920s. It basically means you test every single possible combination. And yeah, it's super thorough, but it has this one massive, and I mean massive, problem. And this is where the scale of that problem just becomes insane. As you add more ingredients or factors, the number of tests you have to run just explodes. Look at this. With just 15 different factors, you're looking at, what is that, over 32,000 experiments. Who has time for that? But now look at the column right next to it. A smarter method, it gets you the answers you need in just 16. 16! That's just wild. So, the big question is, how on earth do you get the same quality of information from 16 experiments that you'd normally need 32,000 for? Well, that's where a Japanese engineer named Genichi Taguchi comes in, and his idea was a total game changer. See, back in the 1940s, Taguchi had this brilliant realization. He figured out you don't have to test every single combination. No way. You just need to test a tiny, really intelligently chosen fraction of them to get pretty much all the crucial information you need. It's all about working smarter, not harder. And the secret sauce to his whole method is something called an orthogonal array. Now, don't let the name scare you. Just think of it like the ultimate cheat sheet for experiments. It's this masterfully designed schedule that makes sure you test the most important combinations without having to test all of them. It's perfectly balanced to give you the biggest bang for your buck. Okay, so here's how the process basically works. It's pretty straightforward. First, you figure out what you're trying to improve, your parameters and levels. Then you pick the right cheat sheet, that orthogonal array we just talked about. Step 3, you actually run the experiments, the small, manageable number of them. After that, you analyze the results to see what really matters. And finally, you run one last test to confirm you found the absolute best setup. Simple, right? It's just a super efficient roadmap. And look, this method is so powerful that it's used everywhere. Seriously, engineering, chemistry, manufacturing, even finance and healthcare. It's all about improving quality and making processes way more efficient. We're talking about saving industries huge, huge amounts of time and money. But what if even that small handful of smart experiments is still too much? What if each one is super expensive or takes forever? Well, now we get to see where this is all heading. Let's look at a real-world example of how this idea gets pushed even further. So get this. Researchers in Baghdad were working on a brand new shape memory smart alloy. It's this futuristic metal, a mix of copper, aluminum, and nickel that can literally remember its original shape. You can bend it all you want, and with a little heat, snap, it goes right back to how it was. Pretty cool stuff. Now, even using Taguchi's SMART method, they still had to run 9 different experiments. And here was the big problem. Every single sample cost over $100 to make, and it took 16 hours just for one. You do the math, that's a lot of time and a lot of money. So this major roadblock forced them to ask a really, really interesting question. What if? What if they could get the insights of all 9 experiments by only actually doing 5 of them? Could they somehow fill in the blanks using modern tech? And their solution is really the next big leap forward in this whole story. They decided to physically run just a handful of the required experiments, and then, here's the clever part, they would use AI to predict the results of the ones they skipped. And that's exactly what they did. They went into the lab and made the samples for runs 1, 3, 5, 7, and 9. But that left these big question marks for the other 4 experiments. The data just wasn't there. To fill in those gaps, they tried 2 different predictive models. One was a more traditional statistical method, and the other was an artificial neural network, or ANN, which is kind of modeled after the human brain. And what they found was that the neural network was way, way more accurate at predicting the missing results.
And here's the magic moment. The neural network was able to accurately fill in the rest of the table. It predicted the hardness values for the experiments they never even ran, giving them a complete set of data without all that extra time and money. And the savings were just incredible. By letting the AI predict the results of just those 4 experiments, they saved almost $1,000. Just like that.
But honestly, the time savings might be even more impressive. They saved over 124 hours of work. That's more than 5 full days of lab time, just gone. Wiped out by combining a smart experimental plan with a smart algorithm.
So, you see, this case study isn't just some clever one-off trick. It really shows us this powerful evolution in how we can solve really complex problems. I mean, think about the journey we've just seen. We went from the old-school brute force method of try everything. Then we got to Tagushi's elegant shortcut. Try a few smart things, and now we're at the future. Try 1 or 2 key things and let AI predict the rest. It's an incredible progression.
And the big takeaway here is that this isn't just for scientists in a lab. It's a real paradigm shift. Thinking this way, using smarter experimental design, saves an enormous amount of time, money, and resources. It makes innovation faster, cheaper, and honestly, more possible for everyone.
So it leaves you with a question, right? What seemingly impossible problem could you solve if you used a smarter experiment? The next time you're facing a huge challenge with a million different options, remember this story. Don't just work harder. Ask yourself, what's the shortcut? Because there's almost always a smarter way.